Welcome to Mastering Solutions. For this, we don't have to draw a ray diagram, we just have to calculate the image position and the image height. So we're going to start by calculating the image distance, and we'll use the thin lens equation to do that, which says that the power of a lens is equal to the inverse of the focal length in meters. That's equal to 1 over the image distance plus 1 over the object distance. We're trying to solve for the image position or the image distance, right? So we'll minus over 1 over s. So we have 1 over the image distance is equal to 1 over f minus 1 over s. And so when we put that in, now we're going to have 1 over s prime, or the image position, is equal to 1 over the focal length. Since it's a converging lens, it will be a positive focal length. So we have 0.3 meters. And this does need to be in SI units. It has to be in meters. If you put in centimeters, even though they're all the same in centimeters, it won't give you the correct answer. We're going to minus the object distance, which it says it is 75 centimeters in front of the lens. So since the object is in front of the lens, this will stay positive. So we have 1 over 0.75 meters. And let's calculate that. So 1 over 0.3 minus 1 over 0.75 gives us 2. And what is that? That is 2 diopters. But we don't want diopters, we want the image position in meters. So if we take the inverse of that, obviously 1 over 2 is going to be 0.5. So we have 50 centimeters, and that was positive, meaning that we have a real image. It's not virtual, so it's also going to be inverted, and you'll see that here in a moment. So it's going to be real and inverted. So the positive or negative for the object distance, it tells us which side of the lens is it on. If it's positive, it's on the opposite side as the object. If it's negative, it's on the same side of the lens as the object. Now, for the image height, we're going to use the magnification equation, which says that magnification is equal to the image height over the object height, or it's also equal to the image negative image distance over object distance. And this section is what we're going to use. And so we'll multiply both sides by h so that we have this by itself. Because now we have all of these. We know what the object height is, and we just figured out what the image distance is, and we know what the object distance is. Now be careful with this one, because when you plug in the image distance, you need to be really careful with the sign on it, because this negative comes from the equation. Sometimes we'll get a negative for the answer, and you need both of them if there's a negative on the image distance. In this case, there's not, so the h is going to be 1 centimeter tall, so 1 times 10 to the negative 2 meters, multiplied by negative 0.5 meters, and then over the object distance, which we said was 0.75 meters. So that's going to give us 1 times 10 to the negative 2, and that's multiplied by negative 0.5 divided by 0.75. So the answer is going to be 0.0067. So if we change this from meters to centimeters, we have 1, 2. So the h prime is going to be negative 0.67 centimeters. So that's the answer for the height. Now, like we were talking about, here, the sign convention tells us if it's inverted or if it's upright. The negative tells us it's inverted. If it's positive, that would tell us it's upright. So we have a real inverted image that's 50 centimeters in front of the lens, and that's 50 centimeters on the opposite side of the lens as the object, and it's 0.67 centimeters tall inverted.